Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shazli binti Kamaruzaman and my supervisor is Dr. Nurul Hidayah binti Kamaruddin, and my panel for FYP1 is IR Mustafa Kamal and Dr. Nasruddin Ali. Today I would like to talk about my research of evaluation of modulus elasticity of palm oil mean sludge modified mixture using non-destructive method. This is my outline. I will explain about introduction, literature review, method and methodology, and expected result. Introduction. Background of study. Pavement describe the series of structure layer. Each layer provide important properties that distribute the stress from traffic loading to the sub-base layer. As we know, Malaysia is the second largest exporter of palm oil. Example of palm oil waste is the oil palm truck, oil palm frond, empty fruit bunch, and palm oil effluents. Palms produce palm oil meal sludge. Due to the scarcity of raw material, there are many research on modification of sulfate binder or mixture with waste material have been conducted. In Malaysia, 9.9 million ton of soil waste consists of empty fruit bunch, fiber, fruit shell, and approximately 20 million ton of palm oil meal effluents are generated every year. Raw homes is often released in nearby river or lands. So, how we want to reduce the waste so that we can protect our environment? Besides that, there are limit study of modification of sulfate binder or mixture with palm oil waste. The objective of the study is to determine the optimum sulfate binder content of AC14 and to evaluate the elasticity properties of palm oil meal sludge modified binder by using ultrasonic plus velocity method. For the scope of study, we are used a sulfate binder with penetration grade 16/17, granite aggregate, and palm oil meal sludge to produce the modified sulfate mixture. For the optimum sulfate binder content for mixed design will be determined by using Marshall method for AC14. And modified elasticity will be tested by using universal plus velocity non-destructive test. We go to the literature review. Here is a summary of the previous research of the modification on sulfate binder. First is the palm oil fuel ash POFA towards the physical properties of modified bitumen by Raja Zulkifli. The test that he do is a penetration, softening point, viscosity test, and penetration index. Second, influence of palm oil fuel ash as a modified on bitumen to improve aging resistance by Heinen. The test is penetration index test, softening point test, viscosity test, and penetration viscosity number. And the third one is the fundamental of rheological properties of oil palm fruit ash modified bitumen by Rio Rusbintarjo. The test is a DSR, bending beam rheometer, and penetration index and penetration viscosity number. Next, we go to the modification on sulfate mixture. First, resilient modulus of porous sulfate using oil palm fiber by Shamoun and Rani. The test, they do a resilient modulus. Second, effect of palm kernel shell ash as a filler on the mechanical properties of hot mixed sulfate by Nobakata and Aguamaba. The test they are do is a Marshall stability and indirect tensile strength test. The third one is the practical use of palm oil fuel ash as a filler in the sulfate pavement by Ahmad. He used the Marshall stability test and the resilient modulus test. Materials and methodology. Materials. I need 3 materials in my research, which is aggregate, palms, sulfate binder. The aggregate I got from Batu Pahat Quarry, and palms I get it from factory processing palm oil. Sulfate binder I need a penetration grade 16/17. This is the flowchart of the research. we got the aggregate, we got alpha binder and POMs, and after that we got optimum binder content, and after that we got ultra pulse velocity data, and then we conclude the research. Aggregate, we have two type of tests. Firstly is a sieve analysis, and second is a specific gravity. For sieve analysis is to help to determine the particle size distribute of the coarse and fine aggregate. This is done by saving the aggregate as per JKR/SPJ/2008 specification. And for the specific gravity, we are using the requirement ASTM D692 of coarse aggregate, ASTM C33 for fine aggregate. Alpha binder test. The first one is a penetration test. The requirement is ASTM D5. This penetration test is examining the consistency of bitumen sample by determining the distance in the 10 of the millimeter of the standard needle penetrate vertically into the bitumen specimen under no loading, time and temperature condition. Second is softening point test. The requirement is ASTM D36. The purpose is to determine the softening point of asphalt. This test consists of two brass ring and two steel ball, using which the softening point of various bituminous materials are determined. Third is a viscosity test. The requirement is ASTM D4402. It is to measure the apparent viscosity of asphalt at handling, mixing, or application temperature. Next is Marshall mix design. This is to determine the mix ratio of aggregate and optimum bitumen content to produce the durable, stable, and adequate of void, workable, flexible, economic, and quality. We are using ACW14. Here is the optimum binder content OBC. This OBC is based on the requirement according to JKR/SPJ/2008. The parameter is of stability, flow, stiffness, air void in mix, and void in aggregate filler with bitumen. Next, ultrasonic pulse velocity. Ultrasonic pulse velocity is an in situ and non-destructive test to check the quality of the asphalt mixture. In this test, the strength and the quality of the asphalt is assessed by the measuring the velocity of an ultrasonic pulse passing through asphalt mixture structure. The higher velocity indicate good quality and continuity of the material, while slower velocity may indicate the asphalt mixture have many crack and void. Expected result. The optimum binder content will be determined for AC14 by using Marshall mix design. Then, the modulus elastic properties of POMs modified mixture will be evaluated by using ultrasonic pulse velocity method. The investigate will base on the effect of POMs 0%, 1%, 2%, 3%, 4%, and 5% to the mixture. Finally, this study will help to understand the characteristic of POM modified mixture. Here is the Gantt chart of final year's project 1. That's it for me. Thank you.